Let's begin. Today's December 9th, 2024, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses the following 5 criteria cards. Criteria cards 4, 7, 15, 19, and 21. And the puzzle uses the green verification cards. The code above is your way to get more information on today's puzzle by searching the code on turingmachine.info. Let's go solve. So in the grid above, we've got our 5 criteria cards. On the top row, we've got criteria card A, criteria card B, and criteria card C. On the bottom row, we've got criteria card D, and finally criteria card E. So criteria card A takes a look at our middle digit, the square digit, and the Turing Machine compares it to the number 4. So should the value of square be less than 4? Should it be equal to 4? Or should the value of square be greater than 4? Criteria card B takes a look at our last digit, the circle digit. The Turing Machine will let us know whether it's an even digit or an odd digit. Criteria card C will take a look at our 3 digits, triangle, square, and circle. And the Turing Machine will let us know which one is the absolute largest. So should triangle be the largest? Should square be the largest? Or should circle be the largest? Criteria card D will take a look at our first 2 digits, triangle and square, add them up, and compare the sum to the number 6. So should the sum be less than 6? Should it be equal to 6? Or should the sum be greater than 6? And finally, criteria card E will take a look at our 3 digits, and the Turing Machine will let us know whether there's a pair or not. So in the case that it's a pair, it could look like our example 131, or alternatively, there is no pair, but there are 2 cases, one where all the digits are distinct, as in the example 134, or all the digits are the same, as in the example 222. And remember, the objective of today's puzzle is to find that unique 3-digit code that abides by all the 5 criteria cards. And we're going to start off with an initial proposal of 314. I think the first thing I'd like to test is criteria card B. Okay, so the Turing Machine does not approve of my choice in circle. I did pick an even 4, but since the Turing Machine does not approve of that, it's letting us know that circle should actually be an odd digit. So let's go ahead and type that up in our notes in section B. And we'll say that circle is an odd digit. And of course, since it is odd, let's go ahead and cross out both evens. Okay. I think the next thing I'd like to test is criteria card D. Okay, so the Turing Machine does not approve of my choice in proposal. Notice that criteria card D is adding up the first 2 digits. So if I add up 3 and 1, that's 4. 4 is less than 6, but since the Turing Machine does not approve of that, it's actually letting us know that the sum of the 2 digits is either equal to or greater than 6. So let's go ahead and type that up in our notes for section D. And so we'll say that triangle plus square should either be equal to or greater than 6. Now I don't think we can actually cross out anything because technically of that equal, 5 plus even the smallest of 1 is 6. And then, obviously anything bigger than 1 would get us something that's greater than 6. The only thing we can at least think about is that triangle and square both can't be small digits, meaning you can't be a 1, 2 or a 2, 1 or even a 1. Yeah, the only thing 1 can really be paired up with is a 5, and that's only if it's equal to 6. So we can think about those, but we technically can't cross out any digits. What else? Well, let's see, I currently do have a circle that is greater than the other digits. That might be a good opportunity. Well, let's go ahead and test criteria card C. Okay, so it is not the case that circle should be the largest. Either triangle or square have to be the largest. Well, let's go ahead and type that up, and again, that's in section C, and we will say that either triangle or square must be the largest. And that is actually rather interesting since, again, we are looking at a solution that's either equal to or greater than 6. So I guess that's a little bit to be expected for either triangle or square. Okay. All right. Well, let's see. What can we say? Well, if that is the case, I think we can cross out circle 5, because if circle were 5, there's nothing either triangle or square could be to be larger. So I think it is safe to say that, yeah, circle can't be 5. Let's see. And I think that's about it. Can't say anything else, I don't think. Well, that does it for this round. We have completed our 3 Turing tests. We're now going into the phase where we'll be discussing how to construct a good second round proposal. And notice that we did not test criteria card A, comparing that middle digit to the number 4. Again, an opportunity for it to be the largest, perhaps. We tested C, but we narrowed it down to either triangle or square, and as well as the sum of the first 2 digits in criteria card D. So we've narrowed those down, and we did not test criteria card E to see whether there's a pair or not. Well, this will be very interesting. One thing I will say about criteria card E is if there is a pair, it must be smaller than the largest, right? If there's an absolute largest, there must be, and if there's a pair, it's got to be smaller. So obviously you can't have a pair of 5s. I don't even think you can have a pair of 4s, because if you have a pair of 4s, we already established that circle is not the largest. So if there is a pair, it would have to be with circle, right? Since we established it's not the biggest, the pairs have to be smaller. So either there's a pair of 1s or a pair of 3s, and we just don't know which one. So is that even something we want to consider? And are there maybe perhaps too many ambiguous solutions? So let's see. What if we do have a pair, it's got to be either a pair of 1s or 3s. And what can we say? I'm trying to see how we can kind of balance, criteria cards A, C, and D all to get us to that answer. So pair of 1s. So if we have pair of 1s, I think perhaps, well, there are possibilities where square could be the largest and it could be equal to 4. Well, let's see, let's say square is the largest and it's 4. Well, I think it would be hard to tell. Let's see. Yeah, I guess you could have, if square is 4, you could have a sum that's less, or it can't be 1. It could be equal to 6, or it could be even greater than 6 if you limit square to be 4. Well, that's a possibility. Yeah. Well, it wouldn't be 1s. And it couldn't be 2 either. So actually, the only possibility with square 4, if, again, square is the largest, would be 3, 4, 3. Because you can't pair up the 2s. So yeah, it looked like if square is the largest, then it would be 3, 4, 3. And it could be that, yeah, square still may be the largest, except it's a 5, and then that would force it to be 3, 5, 3. So it looks like if square is the largest, then there's some possibility of variation of solutions. 3, 4, 3 or 3, 5, 3. That's possible. What else? Could it be, if it's less than and it's the largest, that one I think is a little bit trickier because, well, none of them would add up, triangle and square, to be equal to or greater. So I think those are the only possibilities where square is the largest and it would have to be a 4 or greater. Okay, what if triangle is the largest? Then that would mean that, let's see, we would have to pick, let's see, 3. Again, we're looking for, if triangle is the largest, it couldn't be a 3. I guess it could be, now it would have to be a 5. I think that's the only possibility. Well, no, I take that back. It could be 511 or 533. 511 or 533. If there's a pair, and there are definitely a lot of variations with no pairs. So I'm going to pick something that does have a pair, and I think I'm going to pick where square is the largest. So let's go ahead and pick 3, 4, 3. Let's give that a try. Well, let's see, if it's 3, yeah, it won't be 6, it'll be greater. Yeah, let's go with 3, 4, 3. Let's just see where it takes us. But before, let's double check. Is that last digit odd? It is. Is triangle or square the first or second largest? Yeah, the second is. And the sum is greater than or equal to 6. Yes. Okay. Well, the whole point of that was to see if there is a pair. And let's see. Can we... Yeah, let's go ahead and test criteria card E to see if there's a pair. Okay, so there is not a pair. Okay. Well, we know that since there's no pair, it's either all distinct or all the same. I don't think it can be all the same because we need an absolute largest, and you can't have a triple digit with, they're all equal. There wouldn't be a largest. So that means that I'm going to deduce that it's has no pairs, but they're all distinct. So let's go ahead and type that up. So we'll say that we're going to deduce the solution has no pairs, and then I'll go down here and just say that they're all distinct. Okay, well that definitely puts a twist. All distinct. Okay, well then let's see. The next thing I guess I'll test is criteria card. Let's see, want to establish which one's the biggest, or yeah, let's go ahead and test criteria card C again. Okay, so it is true that square is the largest. So let's go ahead and cross out this section here where obviously triangle is not the largest. Okay, so if square is the largest, that means square cannot be a 1. Because if square were 1, there's nothing smaller for triangle or circle to be. It could be a 2 and so forth. I think that also means that triangle can't be a 5, because if triangle were 5, there's nothing larger for square to be. So let's go ahead and cross it out. I am experiencing a little bit of a lag, so let's see if it'll catch up. So we know, yeah, triangle is not a 5. So what else? We're looking for all distinct solution. There we go. We'll cross out the 5. And I guess let's go ahead and test criteria card A to see if we have a little bit more of a idea what square could be. Okay, so yes, square is equal to 4. So very fortunate there, where we don't have to do too much guessing. We are crossing out everything but the 4 in square. And we are looking at an all distinct solution. So let's see, what else can we... So we know triangle would have to be 1, 2, or 3. Interesting. 4 is the largest. Yeah, this lag is really making it difficult to visualize what our possibilities are. So we do have square 4. Oh, remember that, we still have, I did not realize criteria card D is still outstanding. Do we have a 6 or not? Oh no, we're gonna have to go to a 3rd round. So we know triangle can't be a 1, because that would be a 5. So it's either between 2 or 3 in triangle. So that means it's a 6 or a 7, the sum of the first 2. And let's see, maybe we can deduce it. Well, I'm not sure what I guess I technically wanted to cross out the 2s, the 3s, and the 5s. And let's see what else. So we know that triangle cannot be a 1, because that sum would be smaller. And it can't be a 4, since, again, 4 is the largest. So let's see, what else? And the question is, if circle is 3, that would force triangle to be a 2, since there are no duplicates. So it's either going to be, well, actually, I think it cannot be a 6, because if the sum were 6 and there are no duplicates, how would you choose between 1 and 3? There's no type of ordering going on. So yeah, so I think we can actually safely deduce that the sum has to be greater, forcing it to be a 3 in triangle and therefore a 1 in circle. Yeah, I don't see how you could pick 1 and 3 in circle. Okay, so yeah, so I'm going to deduce then that the sum has to be greater, and we'll just put a note here that we're deducing this. And I forgot to put here that square is equal to 4. That was from testing criteria card A. Square is equal to 4. And then we will say that because we are deducing that the sum is greater, that means that triangle has to be a 3. Therefore, eliminating the 3 in circle to get to our distinct all-digit solution of 3, 4, 1. So luckily we did not have to go to a third round, and I believe that probably would have cost us the game. All right, so let's review quickly here. Is that first digit equal to, is that middle digit, square digit, equal to 4? It is. And our last digit is odd. It is. The sum of, or actually, criteria card C is square is the largest. Yeah, that middle digit is the largest. The sum is greater than 6. It is 7. And we deduce that the solution has, well, technically we knew there were no pairs, but it was eliminating the all equal digit solution. And so, yeah, they're all distinct. Okay, well, it looks like, yeah, that should be our solution of 3, 4, 1. So let's go ahead and verify. 3, 4, 1. And let's see what the Turing Machine says. Okay, fantastic. Yes, that's correct. Well, how do we do versus the Turing Machine? Well, it is a 5 criteria card puzzle. We did have to do 6 tests, which isn't too bad. But let's take a look. We did B, C, D in the first round, all incorrect. And then we did A, C, E in the second, and E was the only incorrect. So let's go ahead and type that up. So B, C, D, all incorrect. And then in the second round, A was correct. We finally got C correct, but we were not correct in the doubles. So how do we do? Okay, so we still beat the Turing Machine by 1 question. Well, hard to know where to pinpoint that. I think in part we were quite fortunate that yes, square was equal to 4, because that would have meant that we'd either have to test something smaller or larger. Maybe we could have deduced it, who knows. But I think that really did play a part, even though we got the pair incorrect. So we were still able to deduce it. Again, a little bit of process of elimination, and obviously noticing that we might have had ambiguous solutions had we picked a 2 for triangle. Okay, well, how about you? How did you solve it? And what criteria cards did you pick? Did you notice anything interesting that you'd like to share? Add those thoughts to the comments. If you liked the video, please do give it a thumbs up. And of course, don't forget to hit subscribe to not miss out on any future videos. Well, until next time, have a great one.